Financial Maths, Geometric Series, Type 3 Pensions. So an annuity is a form of investment involving a series of fixed regular payments made by a person to an account for a specified period of time. And interest is compounded then either at the beginning or the end of each period. A pension fund involves making contributions to an annuity before retirement and receiving payments from the annuity after retirement. So in other words, before you retire, you're paying into an account, and after you retire, you're getting payouts from that account. So it's a bit like savings. When you're paying into your account, your pension equals the sum of the future values. Whereas when you retire, on the day you retire, your pension equals the sum of all of the present values of your future payouts. So depending on which way they phrase the question, you could be looking at what will your pension amount to if you save a certain amount of money every month or every year. Or they could ask you, what would you receive as a payout if this is your pension today and you're getting your payments for 25 years or until the day you retire or until an infinite time. So normally they'd say maybe 20 years or something like that. Okay, so let's look at an example. So here we have Stuart, and he's 35 years old, and he's planning to build a fund for his pension. He intends to retire in 30 years' time, and Stuart wants to have a fund that from the date of his retirement give him a payment of $25,000 at the start of each year for 25 years. So what we want to do here is calculate the value of the pension needed on the date of retirement in order to give him a payment that he wants, in other words, $25,000 at the start of each year. And we're going to use an AEOR of 3%. So this is the first part of the question that we're going to look at. So what does this mean? Well, it basically means that our pension fund is the sum of all of the present values of the future payments from the date of retirement. So in other words, on the day he retires, what happens? Well, we can see that he wants to give him a payment of $25,000 at the start of each year. So basically, if we're setting up our geometric sum, what that means then is that our pension must equal the present value of $25,000 on the date of retirement, where our interest rate is 3%. Sorry, actually we should set that up first. So our AEOR matches our time, so it's our year, so we don't need to change the rate. So the amount that we're receiving is $25,000 at the start of each year. Okay, our interest rate is 3%, which is 0.03. And the time that it's compounded for is going to be 25 years. So what that means then is our pension is the sum of the present values. So the first 25,000 he receives is going to be on the first day. So the day he retires, he receives 25,000, which means we don't have to discount that back. It's not receiving any interest at all. So this is the first payment on the day he retires. Okay, because it's received at the start of the year. So, start of the year. So the next payment he receives then is the following year. And he receives it at the start of that following year. So that one has to be discounted back 1 year. The next one will have to be discounted back 2 years. And so on until we get to the last payment he receives. So on the 25th year, at the start of that 25th year, it's going to be discounted back so we can find out the present value on the day he retires. So, of course, that's going to be 24. Because we started at 0, therefore we still have 25 compounding periods. So therefore the last one has to be discounted back, only 24 years. So in other words, P is equal to F over 1 plus IT, or in this case, our F is basically the amount. So we're finding the present value of each amount received at the start of each year. So we tend to use A rather than F in these questions. Okay, so let's look at that. We can see it's a geometric series. I'm going to take out 25,000 as being common. We don't have to. I'll just find it neater. And then if we look at that, it's going to be 1 over 1.03 to the power of 0, 1 over 1.03 to the power of 1, all the way down to 1 over 1.03 to the power of 24. So therefore, that first term is going to be 1, because anything to the power of 0 is 1. So now I can write down, well, what is my first term, what's my common ratio, and find my geometric sum. So A is 1, or is the common ratio, which is 1.03. So that's less than 1. So our sum to n terms is going to be A times 1 minus or to the power of n over 1 minus or. And n is the compounding periods, which is 25. In other words, there's going to be 25 terms. So again, we started at 0, hence we ended at 24, but that still gives us 25 terms. If I started at 1, then I'd end at the power of 25. So therefore, if we're looking for the sum of the first 25 terms, it's going to be 1 times 1 minus 1 over 1.03 to the power of 25, and that's all over 1 minus 1 over 1.03. That gives us 17.93554212. So I'm keeping all my decimal places until the end. So the less I round, the better. So then I'm going to multiply that by 25,000. And that gives me a pension from the date of retirement. The fund would be 448,388.55. So in other words, €448,388.25 would be the pension fund needed on the date of retirement in order for him to receive €25,000 at the start of every year for 25 years. Okay, so the next thing that we need to look at is, well, if this is the fund that he needs to give him €25,000 every year at the start of every year for 25 years after he retires, well, now we need to look at, well, I'm planning for the future. How much do I need to actually save in order to give me this pension fund that I want? In other words, I need to pay into my account to give me this pension. So as a teacher, we don't have to worry about that because our pension is automatically taken out of our wage. So that money is going into our pension fund on the date that we retire. Whereas a lot of people will look for a private pension fund, so they'll go talk to somebody and they'll say, well, this is what I want on the day I retire, therefore how much do I need to pay into that account to build my pension to the amount that I want to give me a future payment of. Okay? So you're doing two things, paying into the account for the future day that you retire, and then on the day you retire, you'll get a payout from that fund account. So we're told Stuart plans to invest the fixed amount of money every month in order to generate the pension fund that we have calculated. So the first thing it wants us to do is to find this monthly rate of interest, correct to 4 significant figures. So as discussed in class yesterday, sometimes they build you up to changing the interest rate, which is why I always stick to changing our interest rate to match our compounding periods. So our rate is 3% AER. we go back to the question, so we can see it was an AER of 3%. So we need to change that annual equivalent rate to monthly. So we always take P to be 100% when we're changing our rate. F is 100% plus the 3%, which is 103%, in other words 1.03. And therefore I is what we're looking for, and the time is monthly. So therefore we have 12 months in a year. So we use F is equal to P by 1 plus I to the power of T. So we have 1.03 is equal to 1 times 1 plus I to the power of 12. I get the 12th root of both sides, and then get I in its own. And be careful here because it says find the rate correct to 4 significant figures. So when we're finding I, it's always the decimal, and then we need to change it to a percentage and then round. So if we write our monthly rate then, so multiplying by 100, that gives us 0.02466%. So 4 significant figures. And again, in the Leaving Cert, that's generally the way they'll set it up, so that everybody in the country is working off the same rate. So rather than some people using 2 decimal places and 3 decimal places and 5 decimal places, everybody's working with the same rate. So now we know our monthly rate. Part B then says, well, how much does he need to invest at the start of each month? Okay. So the pension fund that we had earned was €448,388.55. Our interest rate, we've just written down, is 0.2466%. And that's going to be 0.002466. And that's monthly. And then our time is, well, when is he retiring, right? So if we go back to the question, he's 35 years old. He's planning to retire in 30 years' time. So that means he's basically going to be saving for 30 years if he starts from today when he's 35 years old. So the time will be 30 years. But of course, our rate is monthly, so we're going to write our 30 years as months. So we have 30 times 12 gives us 360 periods. Okay, so in other words, he's saving every month for 360 months. So we want to know, well, what is the amount that he needs to invest? And he's doing that at the start of each month. Okay, so basically what that means is that our pension is going to be the sum of the future values of the investments. So the lodgements that are going out every month, we need to find the sum of the future values to give us the pension in 30 years' time. So in other words, the way we'd be writing our formula or our equation would be that F, the pension in the future, is equal to P times 1 plus I to the power of T, where P is going to be the amount that's going in at the start of each month. So we're going to have €448,388.55 is equal to some amount times 1 plus the interest rate, so that's 1.002466. And that first amount that goes in is going to sit in the account for 30 years monthly. So in other words, for 360 months. So it goes in on the start of the month and it's earning interest for those 360 months. The next one would be earning interest for 359 and so on until we get to the first or the last amount that has gone into the account. So the last amount that goes into the account, because it goes in at the start of the month, will earn interest for that very last month. And of course we tend to write those in ascending order rather than descending order. So in other words, I'm going to write that as A times 1.002466 to the power of 1 all the way down till we get to the very first amount that went into the account. And it's 1 because it went in at the start of the month. Okay, so we want to take out A as being common there. So we can see our geometric series. So we say A is 1.002466. Our common ratio is 1.002466, so OR is greater than 1. And therefore we're going to use A times OR to the n minus 1 over OR minus 1. And the number of compounding periods is 360 months. So therefore we have 360 terms. So therefore we're finding the sum of the first 360 terms. So that gives us 580.1080215. So therefore we have our pension fund €448,388.55 is going to equal A times 580.1080215. So to find the amount that he needs to invest at the start of every month for 360 months to give us that future pension fund in 30 years' time, ends up being €772.94. So these are the monthly lodgements he needs to make into the account. Okay, so our monthly payments. So if he does this for 360 months, he will have the pension he needs. Okay, so we're going to do question 16 on page 265.